Good morning Okay. Good morning again. Once again, it is Akil Yusuf, the chemistry teacher, in this very important program organized by Jigawa State Ministry of Education, Science and Technology under the leadership of His Excellency, the Governor Alhaji Muhammad Badaru Abubakar. May Allah reward them abundantly. And this important radio station, which is heard, nationwide. I hope everybody in Nigeria is listening to this all-important program, home program, organized to engage students at home in order to make them revise their work, what we have taught them in the school, so that the moment they come back from this vacation or this holiday, they will just squarely face their examination. So thank you. Before we went on this recess, I have told you that we went through with what is qualitative analysis, what is volumetric analysis, and what ions are identified in the process of qualitative analysis, and we have even mentioned the reagents used in the qualitative analysis, and we have taken a simple example of an experiment that can be conducted during WAEC and NECO, because SS3, this lesson is purely for SS3, and the moment they leave home, they go back to school, they will face their examination. That's why we are just hitting the nail on the head. As I've told you that the question, the instruction given in the question will ask you, they will name the sample that you will identify as X, because they will not tell you what it is, X. Then they will ask you to carry the following test on the sample. Divide the sample into 3 portions, for example, add water to it, add sodium hydroxide to the first portion, drop them in excess, make observation. We have gone through all these things up to the point where we said, the ions under influence, the ion present are lead, aluminum, and zinc. So by the moment you come to this point, the question will ask you to add, drops of sodium, aqueous ammonia drop them in excess. And I told you that white precipitate which is observed, if it dissolves, then the ions among these 3 ions, aluminum ion, lead 2 ion, and zinc ion, it is only zinc ion among these 3 that will be soluble in excess aqueous ammonia. Aluminum and lead are insoluble in excess aqueous ammonia. So by the time you are doing this practical, you added the excess aqueous ammonia, you see it's soluble. You don't need to do any confirmation. That itself confirms the presence of zinc. The only problem is when you added excess aqueous ammonia and the precipitate remains, and that is to say it is insoluble. Then you will be left with 2 ions, which you must further carry out more investigation to see which one is present among the 2. So now let's say that you have added excess aqueous ammonia and the precipitate is insoluble. That white precipitate is insoluble. So when you add excess aqueous ammonia and it is insoluble, you write insoluble under observation. Then on the same line under inference, you write Al3 plus and Pb2 plus ions present. Formerly, during our time, we used to say suspected, but YX say you should stop saying suspected because it's not an offense. They say you should say present, so you write present, okay? So after writing that, then the next thing, you must carry out more tests, and it is a question in the WAEC that will lead you to the confirmatory test to ascertain which one is present among aluminum and lead. So if in the question they ask you to add potassium iodide solution to the sample, then definitely you know you are going to confirm lead. Potassium iodide you are going to confirm lead. Or there are two reagents, either potassium iodide or potassium tetraoxochromate 6. These are the two reagents that are used to confirm presence of lead 2 ion. So if in the question, even before you doing the practical, you see that the last one in the identification, in the confirmation between aluminum and lead, if you see they go for this confirmatory reagent, K2CrO4, that is potassium tetraoxochromate 6, or Ki, potassium iodide, you know that it is lead. Just do it to confirm. But even if you don't do it, it is lead, very differently. So when you add, you will see golden yellow coloration. That golden yellow coloration, you write here under observation, golden yellow precipitate. Then under inference, you write Pb2 plus ion confirmed. Then, if on the other hand, it is not lead 2 ion, it is aluminum ion, then they will ask you to add ammonium oxalate, ammonium ethane dioate. That is iopacane of ammonium oxalate, ammonium ethane dioate. When you add ammonium ethane dioate, then you will see white precipitate, and that white precipitate confirms the presence of aluminum ion. So I hope students at home, you are listening to me. If, and I assume and I pray that you understand what I have done so far. You see, this identification, that is to say, trying to differentiate between, precipitate formed by white, ions that form white precipitate. If you are able to do this, you are through with qualitative analysis. Because the remaining ions are 3. Iron 2 ions, iron 3 ions, and copper 2 ions, which I have already listed to you. And these two, they are colored. They are just unavoidable. The moment they ask you to add the reagent, aqueous sodium hydroxide is unmistakable. You cannot mistake it. The moment you add aqueous sodium hydroxide and the sample contains iron 2 ion, you will see green precipitate. No other ion among these ions will give you green precipitate except iron 2 ion. So you see, you cannot mistake this one. All you do is to do your work neatly. Sample X, aqueous plus sodium hydroxide. When you write in drop, you write white precipitate. Then white precipitate, you just write iron 2 ion under inference present. Then you go on with what they ask you to continue. Then in excess, you write green precipitate insoluble in excess, sodium hydroxide. If they ask you to add aqueous ammonia again, it will be the same. It will give you green precipitate insoluble again in excess aqueous ammonia. So now you say iron 2 ion confirmed under the inference. That's why I say for the colored precipitate, in fact, I have done more than 2/3 of the work. Because for white precipitate, the moment you do it for the student and they understand, you are okay. The remaining you just follow up work. So for iron 2 ion, the color of the precipitate is green. For iron 3 ion, the color of the precipitate that will be formed. The process is the same in the case as in the case of the other ion was done, but the only difference is the color of the precipitate and whether the precipitate is soluble in excess of the reagent or is insoluble. For iron 2 ion, it is insoluble in both, and for the iron 3 ion, and it is green precipitate. For iron 3 ion, it is also insoluble in both sodium hydroxide and aqueous ammonia, and it is brown, reddish brown precipitate. So that is for iron 2 ion and iron 3 ion. For copper 2 ion, also is unmistakable. You cannot miss it. The moment you add a few drops of sodium hydroxide to a solution of a sample containing copper 2 ion, there will be a precipitate formed, and the color of the precipitate will be blue. So the blue precipitate indicates presence of copper 2 ion. When you add excess, it will give you, it will be insoluble in excess. In excess sodium hydroxide. But for the addition of excess ammonia, it will give white blue precipitate also if it contains copper 2 ion. But by the time you add SF, here it is soluble. And when it is soluble, it is very, very interesting. You will see it giving you deep blue coloration. Deep blue coloration. So that is for copper 2 ions. I hope it is clear. I will go over what I have said briefly, because you know this is a radio program. It's not a program where you do it in the laboratory and you see. But I know since you have done this practical before, I'm just giving you some rudiments that you need, and things that you may not be able to know, some ideas that you have to put in your mind while you are doing the practical, because so that you will not miss anything. We started giving you the ions that are identified during quantitative analysis, and I told you that they are categorized into 2. There are those ions that form white precipitate with the reagents, effect of the reagents. And there are those that give color precipitate. Color precipitate, we don't, that one is not a problem. But those that give white is where we have problem. Here also, I want to give you a direct hint, that among the 4 of them, zinc is the only cation that give white precipitate, soluble in excess sodium hydroxide and also soluble in excess sodium aqueous ammonia. Is the only one. So zinc is the only one that give white precipitate, soluble in excess sodium hydroxide and soluble in excess aqueous ammonia. Take note of this. So I'm now clear zinc. Again, magnesium ion. Magnesium ion also is the one and only one ion which give white precipitate with sodium hydroxide and aqueous ammonia, which is insoluble in both. Insoluble in aqueous sodium hydroxide and insoluble in excess sodium aqueous ammonia. So it is the only one that gives that. So now I'm left with only lead-2 ion, aluminium ion left, isn't it? And then calcium ion. Sorry, I have not talked about calcium ion. Calcium ion, no problem. Calcium ion is the only ion which gives white precipitate with sodium hydroxide, but has no reaction with aqueous ammonia. No reaction. You add aqueous ammonia, nothing happens. So automatically you know that one is calcium. So that one is also clear. We don't bother. We don't mind that one also, because it's very simple to clear out. So calcium ion give white precipitate with sodium hydroxide, and then no reaction with aqueous ammonia. It's only one that has that kind of property. So we are left with aluminum and lead. So aluminum and lead, I have already explained how they are identified. And also for those that give colored precipitate, I said that one is unmistakable. You can easily see them. Even the blind can see that one. You add your reagent, you see green precipitate, it is iron 2. You add your reagent, you see reddish brown precipitate, it is iron 3. You add your reagent, you see blue precipitate, it is copper. In fact, not only that, anywhere you see a salt, you see a substance green in color, you should suspect presence of iron 2. Ko in animal. Ko akaswa. When you go to the market, you see a salt, blue in color, you should suspect presence of copper 2 iron. I hope it is clear. So that is it. These ions, they are ions of transition elements, and transition elements have D transition. That is what is giving the color. We are not going into that detail. Now we have come to this. We have identified the cations. Now I will go back, because in the introduction of my lesson, I told you that in chemistry, what we normally do is identification of cations and identification of under qualitative analysis. So in this today's program, we are finished with identification of cations. Now we are going to identification of anions. I have told you that anions are also called acid radicals. Acid radicals means they are, ions that are derived from acidic substance. So, in the practicals of WAEC and the NECO and anywhere, even in the university, what we normally do to identify what is present, if it is an anion, we normally make a solution of the substance and heat it, or heat the solid directly. So it depends what the question asks you to do. Sometimes they may even ask you to divide it into two, a solid sample. The first portion you add water to it, then warm gently. Even if they said that anywhere you are asked to warm, you should expect a gas to come out. Anywhere, in any practical, when you are asked to warm, you should expect a gas. And if you are expecting gas, then you should be ready for eventualities. What are the eventualities? One, that this gas that will come out is either of the three. It can either be an acidic gas, or it can be a neutral gas, or it can be an alkaline gas. So therefore, since this gas must be one of these three, you must be ready, and you will be provided. I am chemistry teacher, will always provide anything that the student will need. And thank God, in our laboratories in Jigawa State, I'm proud to say that most of our laboratories are well equipped. Well equipped. So we always provide the necessary materials that you may need to conduct a particular experiment. So therefore, once in the question you see there is heating, you will be required to heat. You bring your litmus paper close to you. And this litmus paper, make sure it is blue and red, because you don't know which the gas that will come, whether it is alkaline or acidic. So it will be blue and red litmus paper close to you. Keep it close to you. Then get your bubbler. You all know what is bubbler. A bubbler is a delivery tube that is bent, and it has a cork. The cork is the size of the test tube, where when the reaction is taking place, you are heating, the bubbler will direct the gas inside the reagent that will react with the gas to show you what gas is present. So the bubbler must be there close to you, and you are provided with test tubes and boiling tubes, which you will do, you heat, direct the gas inside the reagent. Okay? Like I have given you that hint in previous work. Here also I want to give you a hint. That the gases that are identified are either acidic, neutral, or alkaline. So the hint I want to point out here is that this your litmus paper, make sure you use 2 litmus papers. You put your bubbler inside the reaction container. You heat, direct the delivery tube inside the reagent that will test the gas. Then bring your litmus paper close to the mouth of the test tube where the reaction is taking place. I mean the gas, when the gas is generated. The moment the gas comes out, test it with your litmus paper, the blue and the red litmus papers. If the gas is acidic, it will change the blue litmus paper to red. If the gas is alkaline, it will change the red litmus paper to blue. That's why it is important to bring the two together, so that you take care whether it is alkaline or. But if the litmus papers remain the same, the gas is neutral. Now, acidic gases, I will give you a list of acidic gases. Now, you see the acidic gases that we commonly encounter in practicals are as follows: carbon dioxide, CO2, nitrogen dioxide, NO2, sulfur dioxide, SO2, and then, of course, HCl, hydrogen chloride gas. These are the gases that we usually come across that are acidic. Then the only alkaline gas that we usually encounter during qualitative analysis is ammonia gas. So these are the gases. And then I also want to tell you, you have already known it, but I will remind you, because when you did the preparation of gases in your SS2, I'm conversant with your syllabus. In SS2, you have done preparation of gases. All these gases, you have prepared them. You know their physical properties, you know their chemical properties, you know their chemical reactions, and you know their uses. in the test that you conduct to confirm the presence of the gas. So, but I will still remind you that these gases, the carbon dioxide, it depends on the question. You just look at the question, the right question that you are doing that particular time. If the reagents they have given you, like I have said in the identification of cation, here for anion, if the reagents they have given you, if you see lime water, then just be rest assured that the gas that will come out is carbon dioxide. I hope it is clear. The moment you see lime water, they ask you to bubble the gas through lime water, just suspect carbon dioxide. So I hope you will go back, study, revise, use these your gases, revise their physical properties so that by the time you are testing them, you know what they are, you see. And again, another leakage I will tell you is that if among the reagents that they ask you to bubble the gas through, or among the reagents they ask you to add to the solution of another to find out the negative ion, the anion, if you see silver trioxynitrate 5, if you see silver trioxynitrate 5, you identify chloride ion. I hope it is clear. And again, if among the reagents that you are using to test for presence of an anion, if the reagent you see barium chloride, you are going to test for presence of SO2, sulfur dioxide. So I've now mentioned 3 reagents. Each one you should know what it is testing. Lime water is testing carbon dioxide. Silver trioxynitrate 5 is testing chloride ion. And the other one which I said is carbon dioxide, sulfur dioxide, then lime water, which is used to test for carbon dioxide. So this is it. Then I want to also tell you the color also that you will see when you are testing for carbon dioxide. The color of the lime water. The lime water is a colorless solution. We prepare it and give you in the laboratory to test for presence of the gas. So once you bubble the gas through the lime water and the lime water turn milky, then you know that the gas that you bubble through this lime water is carbon dioxide. And to confirm it that it is really carbon dioxide, you continue bubbling it. When you continue bubbling it for a long time, then definitely you will see the milkiness disappears. So if the milkiness disappears, you will confirm presence of carbon dioxide. So this is it. And then the next one, in summary, the next one is silver trioxynitrate 5. If you add silver trioxynitrate 5, the color change is white precipitate. And this white precipitate is soluble in aqueous ammonia. So white precipitate soluble in aqueous ammonia confirm presence of chloride ion. No mistake about that. I hope it is clear. But the time you add freshly prepared ion 3, ion 2, followed by compressed USO4, you are testing for trioxynitrate 5 ion. And that one will give you brown ring around the junction between the 2 solutions. That also confirms presence of NO3 ion. So I know I've taken much of your time. So because of that, I would like to stop here until we meet next time. Thank you very much. And I pray that inshallah, things will be over and you will get back to your schools and write your practicals. Use these techniques that I have given you to deal with chemistry questions. Thank you.